Okay, ladies and gentlemen, so what we're looking at here is Lesson 8, officially starting with the handouts from your photocopied package that you were handed, and I believe we're on page 58 of that package and Lesson 8, complex numbers. So we have a certain problem here, and it's solve x squared plus 1 equals 0. So when we try to solve it, we try to isolate for the x squared. So we take the 1 over to the other side, and we come up with this, which we have here, and you'll notice that that took us to the situation where we need a new number. Okay, so you need a new number to help with that, and that new number that we came up with is I. And so there is no such number as the square root of a negative in the real number system. This led mathematicians to invent or discover a new number defined as the principal square root of negative 1. So the principal square root meaning the positive square root of negative 1. And with the addition of this new number, a whole new number system was then created, giving rise to what we call the complex number system. This new number I is defined by being the square root of negative 1, and I squared is going to be defined as negative 1. A complex number is written in the form a plus bi. Now this is a complex number where this part is called your real part because that's a real number, meaning it comes from the real number system. And this is the imaginary part, meaning that it has an I on it, which is the imaginary unit. Okay, and where a and b come from the real number systems. So an example of a complex number would be 5 plus 2i. So the whole thing is a complex number. It has 5 as the real part and 2i as the imaginary part. This is a complex number. It's got 4 as the real part and negative 3i as the imaginary part. If b was to equal 0, then b plus bi would equal just simply a. So if b was 0, there'd be no imaginary part. That would just give you a real number, such as 5. Therefore, all of the real numbers can be thought of as part of the complex number system. And it would be written as 5 plus 0i. Now, if a equaled 0, then a plus bi would be 0 plus bi, meaning that all pure imaginary numbers can also be considered complex numbers. Therefore, complex numbers in which either a nor b are equal to 0 are referred to as imaginary numbers. So complex numbers in which neither a nor b are going to be referred to as imaginary numbers, whereas up here, this is just a pure imaginary number. Okay? I think that's about it, and we can move on from there.